Practice to increase articulation with mouth exaggerations. Reading the article from TechCrunch about everything you know about computer vision may soon be wrong. Ubisoft wants half of the world's cameras to see things differently by Haye Jan Kams. Haye Han Kams. Yeah. Written on March 10, 2023. Computer vision could be a lot faster and better if we skip the concept of still frames and instead directly analyze the data stream from a camera, and instead directly analyze the data stream from a camera. At least that's the theory that the newest brainchild spinning out of the MIT Media Lab, Ubisoft, is operating under. Most computer vision applications work the same way. A camera takes an image or a rapid series of image. In the case of video, these still frames are passed to a computer, which then does the analysis to figure out what is in the image. Sounds simple enough, but there's a problem. That paradigm assumes that creating still frames is a good idea, as humans who are used to seeing photography and video, that might seem reasonable. Computers don't care, however, and Ubisoft believes it can make computer vision far better and more reliable by ignoring the idea of frames. The company itself is a collaboration between its co-founders. Sebastian Bauer is the company's CEO and a postdoc at the University of Wisconsin, where he was working on LiDAR systems. Tristan Swedish is now Ubisoft's CTO. Before that, he was a research assistant and a master's and PhD student at the MIT Media Lab for 8 years. There are 45 billion cameras in the world, and most of them are creating image and video that aren't really being looked at by a human. Bauer explained. These cameras are mostly for perceptions, for systems to make decisions based on that perception. Think about autonomous driving, for example, as a system where it is about pedestrian recognition. There are all these studies coming out that show that pedestrian detection works great in bright daylight, but particularly badly in low light. Other examples are cameras for industrial sorting, inspections, and quality assurance. All these cameras are being used for automated decision making in sufficiently lit rooms or in daylight. They work well, but in low light, especially in connection with fast motion, problems come up. The company's solution is to bypass the still frame as the source of truth for computer vision and instead measure the individual photons that hit an imaging sensor directly. That can be done with a single photon avalanche diode array. A single photon avalanche diode array. Hope I'm not wrong in pronounce that. Or SPAD array among friends. This raw stream of data can then be fed into a field programmable gate array or FPGA, a type of super specialized processor, and further analyzed by computer vision algorithms. The newly founded company demonstrated its tech at CES in Las Vegas in January, and it has some pretty bold plans for the future of computer vision. Our vision is to have technology on at least 10% of cameras in the next 5 years, and in at least 50% of cameras in the next 10 years, Bauer projected. When you detect each individual photon with a very high time resolution, you are doing the best that nature allows you to do. And you see the benefits like the high quality videos on our web page, which are just blowing everything else out of the water. TechCrunch saw the technology in action at a recent demonstration in Boston and wanted to explore how the tech works and what the implications are for computer vision and AI applications. Period.